So, Jiva, if I was excited about the last one, then because we're fulfilling promises, then with this one, I'm mega excited because we've been talking about memory management since it feels like the beginning of time, and every time we come across it, we say, "Well, don't worry, we're going to get there. We're going to get there. We'll cover that later. We'll cover that later." Well, later is here, so I guess after all the build-up, it better be good.
Time to start fulfilling promises. So if you're coming to Objective-C from another language such as Java or Python or Ruby, you might be surprised to find out that you have to think about memory management at all. Most of those other languages really handle your memory management for you. They have like garbage collection systems and things like that that take care of the housekeeping details of memory management. Now, Objective-C does have a garbage collected runtime, but it's a relatively new addition to the language. It was only added in Objective-C 2.0, so it's only available on macOS 10 Leopard. In addition to that, it's also not available on iOS at all. So if you're either working with a legacy code base or if you're doing any kind of development on iOS, you still need to think about managing your memory manually. Fortunately, if you fully understand all of the rules of memory management and so forth, you'll find it's actually a lot simpler than you might think. Now, just to be clear, we're going to be covering both the retain counted memory management model, which is the traditional manual memory management model, as well as garbage collection. There's things that you need to know about both of those. But first, we're going to start off with the traditional memory management model.
Okay, sounds good. So
before we actually begin looking at code, we need to kind of discuss a little bit of theory here so that we understand kind of what's going on under the hood. What's it really mean to have a retain counted memory management model? And the answer is, so every object in Objective-C that inherits from NSObject, which as we know is ultimately all of them, right? Inherits certain behaviors associated with memory management. So these behaviors allow you to work with and manage an internal counter called the retain count. The retain count is basically a count of the number of entities or other objects that have said that they are using a given object, right? And so therefore, that object needs to be kept alive and kept around so that they can continue to use it. So using these methods, you can increment or decrement this retain count, enabling you to essentially kind of lay claim to or give up your rights to that object.
Right.
So if you increase the retain count, you're saying, I need to keep this thing around. If you reduce the retain count, you're saying, I'm done using it. So as you work with these methods, the Objective-C runtime knows that when an object's retain count reaches 0, right, which means that really there's nobody else who cares that that object sticks around, then that object can be released. It also knows that, or can be deallocated, I should say. It also knows that if the retain count is greater than 0, then there's at least one other object out there that's counting on that object being alive. And so therefore, it's not allowed to deallocate it. Because if it deallocated it, then when that object went to access this object, it would crash because the object's no longer there. You're off into, la la land. So essentially, that's really the core of how the retain count memory management model works, right? The runtime knows that an object with a retain count of 0 can be deallocated, but because nobody else needs that object, and if it's got higher than that, then it can't be. That's the core right there.
So I guess, unlike maybe a traditional C model where we're actually having to allocate the memory with a malloc and then free the memory and whatever else, and often tracking when we can do that is difficult. This solves a lot of that problem because it's about people can register interest, but it doesn't remove the responsibility.
Correct.
To say I am using this, I am not using this.
Correct. And
if we don't do that properly, I guess there's going to be consequences along the way.
Right. And in a lot of ways, we talk a little bit about responsibility and things like that. In a lot of ways, it kind of comes down to if you just behave a certain way, if you make sure that you follow certain rules, then you almost don't even have to think about it. It's a little bit like like the free market system. You know, when you follow certain rules to a certain extent of self-interest, then things work out well. And we'll talk about those rules towards the end of this segment. So the next question is, you know, if the runtime relies on the retain count to do all of this memory management, you know, how do we manipulate that retain count? What are these methods that that allow us to increase and decrease the retain count and things like that? And it really comes down to this. There are methods on NSObject. So again, they're inherited by all objects, including yours. And if any of the methods that you call contain the words retain, copy, or create, or if you use the class method alloc, okay, anytime you use any of those methods, and I'll show a slide later with these names on them as well, so you can wait for that to write those down because they're really important. Retain, copy, or alloc, or create. Anytime you use any method or on an object containing any of these words, you have to assume that the retain count on that object has been incremented by 1, right?
Okay.
In the cases of create or alloc, usually this means that the object that you've gotten back has a retain count of 1. But if you can just, kind of assume that I've gotten a retain counted object from this thing, that's all you really need to think about. On the other end of the spectrum, right, to decrement the retain count, you call the method release. Calling release will decrease the retain count by 1. So another thing to realize out of that is when the retain count reaches 0, then the object will be deallocated right there on the spot when you call release. So let's take a look at a quick code example. So, you know, again, we've got just plain old templated code here, nothing special. In this code, we've got this auto-release pool that we'll talk about in the next segment because that's actually important for memory management as well.
I'm glad to say, you know, that now we've reached memory management, we're finding other things to say. We'll do that later.
Exactly.
We want to keep the tension running.
Well, fortunately, that's next. Auto-release pools are going to be next. So for now, we'll just leave that there. The important thing to know is that is related to memory management, but that's not important to this particular section. So again, you know, if you have an object, let's say we've got a foo, right, and we do foo alloc init, right? Just like that. Mm-hmm. Then foo at this point, if we do something with foo, whatever, right? Foo there has a retain count of 1.
Because alloc, the word alloc is in there, that increments it. Exactly. From 0 where it was created.
Exactly. Now, if we also do foo, let's say we do a foo retain here, right? Then at this point, the retain count would be 2 because retain will increase the retain count by 1 as well.
Okay.
Now, if we do a release here, remember the release decrements the retain count. So at this point, we're back to 1 again.
Right.
Then if we do another release, the retain count goes to 0, and our object's dealloc method will be called, and all of its memory goes away. If we try to do anything with foo at this point, that results in a crash.
Right. Okay.
Well, technically, I guess it's possible it might not crash, but you have to assume that it will.
There's going to be problems.
Yes.
And that's the problem. It may or may not crash.
Right.
But
do you really want to program that way?
Yeah. I mean, I guess it might be worth just saying that the only reason it may or may not crash is when an object is actually released. All it means is its memory is made available for reallocation.
Right.
It doesn't mean that memory is actually cleaned up.
Right.
It gets reallocated, it gets cleaned up.
Right.
So if nothing else yet is asked for memory, there is a chance that your object is still sat in that memory and will still work.
Right.
But at any moment now, it could go away,
right,
or whatever else.
Right.
So it's hit and miss program, which is why it may not fail for another 3 routines or whatever when something else uses the memory, which is almost impossible to track down.
Right, exactly.
So don't get it wrong.
Right. Yeah, you have to assume that when your retain count, when your kind of internal thinking about it retain count has reached 0, when you have not got any more ownership of an object, that you can't go back and get it is kind of ultimately what it comes down to. Now, I mean, here, of course, I've done, typically you probably wouldn't do something like this where you've allocated it and then you retain it and then you release it twice. Typically, you're going to do something like this where you're going to allocate this guy, you're going to do something with it, and then you're going to release it.
So now that's good memory managed code.
Right there. Pretty simple, pretty straightforward. The important thing to remember is just alloc and release. Or, again, any of those methods that increase the retain count, you have to remember to release that retain count as well. You have to decrement that retain count. So another case might be, for example, let's say that instead of allocating my object myself, what if I went and I got it from another object, okay? Let's say I had a bar sitting here and I said, get foo, right? Now at this point, do I have an object that has, what's the retain count on this object? What can I assume that the retain count is?
It's whatever it already was inside of bar, I guess.
Right, and so, but you don't know what that is, right? So you have to assume at this point that I didn't get something that had a retain count that I can use. In order for me, if I want to hold on to this thing outside of the scope of this particular method, then I need to retain it, right? So if I wanted to keep this thing outside of this particular method, then I would need to retain it. Now, if you only wanted to use this inside of this method, it's actually okay to go ahead and just use it there, because we'll talk about something in a moment where we'll explain how it is that you can use it right here in this method and you don't have to retain it here. But again, let's say that you were actually assigning this to a member variable on one of your objects, right? In order to keep that guy around outside of the current stack, you need to retain that guy. Make sense?
Yep.
So same thing. Now let's say instead I did something like that, except I get my square bracket correct, where we're getting this thing from bar, but we've done a copy on it. So the method name
got the
contains
object,
copy.
and we've called copy on it, which means it's going to make a copy of itself,
right,
and give it to us. Now you said the rules were if it was copy, we can assume it increments a retain count. Then
I do have a retain count that's been incremented there, and therefore I don't need this retain here. I will need to later release it, but I don't need to retain it again.
So this brings us back to your simple rules. If it contains an alloc,
right,
a copy, a create,
right,
and obviously the retain call itself,
right,
will all have incremented the
exactly.
retain count on an object.
Exactly.
If we get it back from anywhere else, we can assume it's safe to use within our current scope.
Yep.
But if we want it to stay around, or we want to guarantee it's going to stay around,
yes,
beyond our current scope, we need to register our interest in it by incrementing the retain count ourselves.
Precisely.
And any time that we are responsible for the retain count being incremented, be that through the alloc, the copy, the retain, it's our responsibility to make sure it gets decremented
through
with the release.
Yes.
That's reasonably simple. I know it can cause problems at times, remember that, but that's actually not that complicated, is it?
It's not that complicated. By the end of this talk, we're going to give you some key rules that if you just memorize those, it's going to be dead simple. Even this may seem a little bit complicated, but it's going to be dead simple by the end of this particular segment.
I'm glad you said that. I thought you said, don't worry, we'll make it complicated.
No, we don't want to make it any more complicated. So basically, so now you've seen, that's essentially how you increment and decrement the retain count, is by using those methods. Now, I did mention, one of the method names that you have to assume the retain count you own the object from is a method with the word create in it. Typically, the create methods are actually things that you'll get back from some of the core foundation libraries. Those actually use these create functions for creating things. So you don't usually see those so much in the foundation frameworks, because they stick to the alloc and the copy and so forth. Create is something typically you see more with core foundation. We don't really cover core foundation too much in this particular class, because that's more of a C-level thing, and we're really talking more Objective-C. But I just wanted to point that out, and you should, when you're remembering these rules, remember that create is one of those rules. Okay.
Okay.
Now, I also, let's take a look at one other example just for the sake of looking at something that we saw yesterday, which was, let's say that I've got an NS array, and I'm creating it by doing NS array alloc init. Right?
Yes, yesterday for us may not be for them.
Right, you're right. Sorry.
They may go faster.
They might go faster.
But don't worry.
Okay,
at least they know now that we've been here a long time.
Just for you.
Yeah.
Okay, so here's an array, and we're allocating it and we're initializing it. So what's the retain count on this guy? Just right at this point. On the array object.
1?
It's 1, right?
Yeah.
Now, before, when we looked at an array that we created for our object that we passed in, we did something a little bit different, right? We used this thing that looked like this. Okay, and that's still creating an array. So what's the retain count in that case?
1?
No, it is not, because
okay,
you know this stuff. Because the method that we're calling to get that array, does it contain alloc, create, or copy?
But that's an implementation detail. We don't necessarily know.
Well, that method right there, NS array.
That's creating an array for us.
It is creating an array for us.
But we ourselves are not calling alloc new or copy. The method may be internally, but we're not.
Well, we don't know. But based off of what we've said, because that method does not contain copy or create or alloc, because that's nowhere on that line, we have to assume that the retain count at this point is 0. Well, we have to assume that we don't own the object.
We have no interest, registered no interest in it yet.
We have registered no interest in it yet. The alloc, the copy, and so forth, that registers our interest in it. At this point, we haven't registered any interest in it. We would have to, if we want to keep that around, we need to keep that around.
So this one falls into the rules that it's fine
to use it within
this scope, but as soon as it goes out of scope, it will get cleaned up nicely.
Right.
Whereas if it contains an alloc, a copy, a retain, or a create, when we go out of scope, it's still going to be there and it's not going to get cleaned up until we tell it to.
Right. Now you're introducing there kind of what we're going to talk about next, which is, you said it's going to be cleaned up nicely. And, what do you mean it's going to be cleaned up nicely? Where's that coming from? And the answer is there's actually a special case for all of these other situations where you're going and you're getting an object and you don't know whether it's had its retain count incremented or whatever. Essentially, what happens here is an object that you get from any other method that is not with those alloc or copy and so forth is what's called auto-released. Okay, and what that means is that the compiler or the runtime has made a promise that sometime in the future it's going to decrement the retain count on that object. Right. So in fact, actually, what you're getting back here is in fact you're getting back an object that has a retain count of 1, but the runtime eventually in the future, in other words, sometime after you leave the scope of your code here, will decrement that retain count automatically for you. When it does, that object's going to go away.
So that's why it's safe to use this within our scope.
Right.
Once we go outside of our scope, at some point,
exactly,
which we don't need to worry about when it's going to disappear.
It's sort of an implementation detail of exactly when that's going to go out of scope. But the important point is, as soon as you lose control of the thread of execution here, you need to assume that it will go out of scope. So in other words, when it leaves your current method, anytime the run loop can run, it's going to possibly set that retain count to 0, and then that object's going to be deallocated. So again, if you need to keep it around outside of the current scope of your method, you better retain it.
Which is still following the rules because it doesn't contain an alloc, a create, or a retain, or a copy in the method. So we're still just following the rules.
Exactly, you're just following the rules. So let's look at a quick example of why we have to do it this way. If you consider the case of, let's say that I've created a function or a method that actually creates one of these guys, right? Foo equals so I've created this guy and I want to return foo, right? Now, if I return it just like that, then what if the calling method for this guy, let's say I'm actually calling this from another method. Oops. And I say self some method. So if I look at this code just as it is, right? When I call some method, of course, I have the option of doing anything with that return value at all. You know, maybe I do something with it, maybe I don't. In this particular case, you know, if I assign this, if I say foo pointer foo equals, right, then I've got it there and I can release it. But if I don't do anything with it, if I just want to ignore the return result, maybe I'm doing this because I've got some side effect or something that I want to call some method for, then what happens to that foo object?
Well, even when you had it assigned, you're not going to release it, are you? Because that's not one of the rules.
Well, right, that's correct. It wouldn't be one of the rules.
So what's going to happen is that foo object that was created in some method is never going to reach 0 on its retain count and therefore never go away.
Which is a memory leak.
Yeah.
And we don't want that, right?
No.
So that's really the whole reason that auto-release was created, was so that we could return these things, and if the caller doesn't have any reason to hold on to it or keep it around, you can just forget about it. It doesn't matter, right? It's very simple and a very powerful capability. So, so we've talked about incrementing the retain count. We've talked about decrementing the retain count. So again, you know, alloc, copy, retain, all of those things create
new.
Because it's
See,
a, that's a
gonna
tricky one.
new.
All right, we'll ignore new.
But
someone might see some code with new in it.
Yeah, I use new too, and so I do use new, but I've been told that new. So okay, let me give you a quick example.
I'm sorry, I've just messed up the whole segment.
No. So there is a shortcut in that was part of the original Objective-C language. So for example, you could do array like that, okay? And actually what new does there, new is another one of those methods on NSObject that all it does really is it just calls alloc init. And it's a nice, you know, clean, quick way to do things. Older books on Objective-C, some of the original books on Objective-C used this shortcut in some places. And some of us, you know, older guys who've been doing this for a while probably use new in our code here and there. But I think it's sort of a deprecated standard. I think mostly people don't use it too much. But if you see new, then that you have to kind of mentally say it's doing an alloc init. So it's the same kind of thing. It's new is also one of those cases where you need to have where you have to assume that the retain count is 1 there. But anyway, so coming back to sort of the key of understanding retain counting memory management, it really boils down to a concept of object ownership. That's really, you know, if you want to kind of, you know, I guess if you take nothing else away from this particular segment, the most important thing to understand is it's really about object ownership. When you increment the retain count on an object, you're essentially stating, I want to have access to this object until I say otherwise, right? When you release that object, when you decrement the retain count, either through an auto release, right, or a release, you are relinquishing any ownership you have to that object. And that reminds me, actually, we didn't actually show the auto release here. So the way to actually solve this problem here is you actually do an auto release here. Okay, and so you're actually going to call that. That's the actual method call that you make to return that auto-released object.
So that Whereas release, it decrements it straight away.
Right.
And if it reaches 0, it will go away.
Right.
Which obviously in this case it would, because
Right.
it's only just been created.
Right.
Auto release is saying, when you get the next opportunity within the run cycle,
Right.
you can release me.
Exactly.
Now, the reality is we know that that is not going to happen until some point when our current scope relinquishes responsibility back to the run loop. So within the scope of where it was called, it is safe.
Right.
But outside of that, not. So the person calling it, as we've said, can then retain it if they want to keep it longer.
Right. So the important thing there is whenever you are returning an object that you have allocated inside of your method, or an object that you have, copied or retained, then you want to auto-release that object when you're returning it. The nice thing about the auto-release method is it actually returns the object that you're calling release on. So you can do exactly like this code is showing here, where we're doing, return foo auto-release. That'll actually return foo, but it'll be an auto-released foo.
Wonderful. So that's for all, when we were talking about our class methods and creating factory methods and any methods we write like that return objects, that are creating objects in them, we need to make sure we auto-release those objects before returning them.
Right, right. Unless, of course, it's one of those methods, the method that you're writing is one of those methods with those names.
So if we write a copy my object method, we should return it unauto-release, because that's what people following the rules will be expecting.
Correct. One other example, the NSArray method that we saw here, that we're using here, would really kind of boil down to something like this on NSArray, where...
Needs a plus.
Oh, you're right, plus, because it's a class method. Where you're going to do... it would probably do self, but I'll put NSArray here just so
we can read it.
A little bit clearer. That's ultimately, see if I got all my square brackets correct. Yes, that's ultimately probably what the NSArray array method actually is written as. There's probably some other implementation details in there, but if you were writing a similar factory method for one of your classes, essentially that's what you would wind up writing. So you're allocating it, you're initting it, and because you've allocated it, you have an object with a retain count of 1. You've said, I want to own this thing. But really, the truth is, you don't really want to own it. You want to give it up to somebody. So therefore, you have two choices. You can either release it, which wouldn't be very good because you're returning it from your method, right? Or you can auto-release it, which basically says, hey, runtime, will you release this for me in the future? Make sense?
Makes perfect sense. And that actually, I think, is the first time we've seen code that gives a great example of just keeping embedding calls on objects.
Calls on calls, yeah.
On calls. Because we have the return from the alloc, which we then call init on, and the return from the init we're calling auto-release on, which is what's going back.
Exactly. We saw that a little bit yesterday when we were talking about the other, when we were talking about making calls on objects and things like that. But yeah, this is a really good example of where you have, call upon call upon call. And, you can keep going if you wanted to. So I said that we'd have some rules up here that we could talk about. So let's review those rules. So the first rule, memorize these rules. Okay, if you memorize these rules, I guarantee you life will be much easier. So the first rule is, remember, alloc, copy, or create, okay? You own it, all right? You need, therefore, to release it, either through an auto-release or through a release, one way or another. If it's something that you're storing, even if you retain that object, if you're allocating it and you're putting it as a method or as a member variable on one of your classes, right? You're still responsible for some time in the future releasing that. And the appropriate time to release a member variable would be in your dealloc method. And so that's where you would have to call that release for that. That's sort of the bracketed side of that.
So dealloc is what gets called, right, going back to when we were creating init, and dealloc is going to get called when the retain count reaches 0. Part of that cleanup process is dealloc. and we need to make sure in there that any other objects we're holding on to within our objects are getting released properly as well then.
Right, exactly. So rule number 2, all other objects that you get back from other methods or whatever, you don't own, okay? So if you want to keep them, you need to retain them. Again, you know, if you want to keep an object as one of your member variables or whatever, you need to retain that guy, right?
Okay, yep.
And finally, whenever returning an object from a method whose name does not contain alloc, copy, create, and so forth, init doesn't need to be in there because that's you're going to use an init with an alloc. You need to return an auto-released object. Okay, so anytime you're not returning something from an alloc, a copy, a create, I guess init is good to have in there because when you're writing initializers, right, you're not going to be auto-releasing those guys.
No.
Because that's you know, because you actually got that object from an alloc. So so you need to be returning an auto-released object at that point. Does that make sense?
It's all pretty simple, really, isn't it?
It is. If you follow those rules, it really is pretty simple.
Okay, so I don't know. This may be the wrong time to ask this question. In which case, you can defer us till later. Keep us excited. This now brings me back to something we were looking at a little earlier in properties. Okay, because one of the options we could make on a property was retain.
Yes.
So I'm assuming that means that the setter method that it's using, when we set the object, is going to retain what's coming in.
Yes.
Another one was copy,
Yes.
which means it's going to issue a copy about what's coming in.
Yes.
So I'm guessing that means, you know, even though we're not calling retains ourselves or copies ourselves, that suggests to me that we still need to make sure that the member variables that those properties are being stored in do get released in the alloc method, or the properties sort that out automatically for us.
The properties will not do that automatically for you.
So that's still our responsibility.
It's still your responsibility. But it's nice to know that, you know, so you can set your properties with these, you know, retain, copy attributes, right? We saw that before when we were looking at properties. So, and really what that means is you're setting the memory management rule just for the setter and getter on that. And so when somebody sets one of those values, one of those properties on your object, then that value that's being set will be, for example, retained if it's a retain attribute, or copied if it's a copy. So then the data that's associated with that member variable will be retained or copied based on that rule. Let's do a quick class here so that we can see kind of how that affects our classes and how memory management affects our classes and so forth.
Okay.
If we created a new class and just added it to our code here and just call it, well, let's create the foo class, right? So now we've got this foo guy, and let's say that we added a string called property or something, prop, and we created a property for that, and we set it to, well, if we don't set any attributes for this, and we just say in a string pointer prop, okay? You may recall when we were talking about properties, right? The default attribute for memory management is actually just a sign.
Which literally means put an equal sign in there.
Put an equal sign in there. So just like this, there's no retain, no copy, nothing like that going on here, okay? So in other words, in that case, if you're counting on that variable being kept around and it's an object, you'll have problems because remember, you need to be retaining that.
We've never told anyone we're interested in it. At some point, that's
exactly
going to get released because something else is reducing the retain count.
Exactly. Now, if we do a copy here, okay, well, let's do a retain first. If we do a retain first, if we do a retain for the attribute there, then when somebody sets the property, the prop property on this object, then the setter that we've had generated here will retain that value, and we have to make sure that we release it. And the place that we release it is in our dealloc method. And I'll show you in a second a little bit more detailed look at the deallic method. We saw them yesterday. We were, kind of glanced over them because, again, it was one of those cases where we'll come back to this when we talk about memory management. Now's the time to fulfill that promise, right? So again, if you set the retain attribute here, then that guy's going to be retained and you have to release it, right? Finally, if you come back in here and you say copy, right, on that line there, same kind of thing, right? Because the setter is going to do a copy, so it's going to make a copy of that value when it comes in, and that means that, again, you have to release it. Now, the copy attribute is actually going to copy the value. When you do a retain, you're essentially saying, I just want to keep the original value, right? And so it's possible that that value is going to be shared with other objects. And it is entirely possible that those other objects might make changes to those objects after the fact, okay? If you're familiar with some languages like Python, for example, or Java, where everything's treated as a reference, by default, you don't really have exclusive ownership to most things, then that might not be a big deal to you. But some people who are not so used to kind of sharing their data with everybody, that can be very disconcerting. So you might consider using copy instead. When you use copy, you actually make a full-on copy of that. So if I've got somebody who sets prop here, and he's setting it from his own version of prop in himself, instead of essentially both of those versions of prop pointing to the same location in memory, which is what happens when you just do a retain, instead you'll actually have two separate chunks of memory that are copies of each other. And if he changes his, that's okay. If you change yours, that's okay. They don't affect each other, okay? Now, I have heard some people say that because of that, they prefer to use copy for all of their setters. Personally, I think that's overkill. I think it inflates memory too much, and I don't really like to do that. But I don't know, what do you do? Do you prefer copy or retain?
It depends. I have to say with strings, I tend to use a copy, although I couldn't necessarily justify that because I guess strings are immutable. We'll get to that when we get to strings. Whereas definitely for a mutable string, I would do a copy because that's where things do change. I guess the answer is it depends what mood I'm in.
Fair enough. Fair enough.
Or why I'm doing it or what I'm doing. I have no hard and fast rule.
Fair enough. Okay, so now we've got this guy. Let's say that we've set a copy attribute on this property. Now remember, again, that means that eventually, because our object owns this property object, that we need to eventually release it. In particular, when and the right place to do that is in our deallic method, because that deallic method is what gets called when our own retain count reaches 0. So if our foo object gets released, its retain count goes to 0. The runtime then calls our deallic method, which must take responsibility for releasing correctly all of the memory that it has claimed ownership to, right? So the appropriate thing to do in the deallic method at this point then would be to take our prop and set it to, or go ahead and do a release on it, okay? Now, one thing that, so at this point, we're clear, we're clean. We've done all of the memory housekeeping that we need to do for this property on this object. This would be okay as is. One of the best practices that's probably a good thing to do is whenever you release an object, you should also set the original variable to nil, okay? Now the reason you do that is in Objective-C, the nil value, there's a special property of Objective-C. If you've come again from Python, virtually any other language, Java, C, C++, you're probably familiar with the concept of null, right? And null is kind of on the same wavelength as nil. It really means a non-value. In those other languages, though, if you have a pointer or an object that's been set to null and then you try to access it after the fact, what happens? Your application crashes. In Objective-C, exactly the opposite happens. In Objective-C, it's actually perfectly fine to send messages to nil. However, if you do so, nothing happens. You get back nil as a return value, nothing happens in the runtime, and so on. So it's generally a good practice to set variables that you have released to nil, so that if, for example, just as an example, let's say that somewhere between doing our release here, okay, and finishing our deallocation at the end of this dealloc, somebody went and accessed the property on this object and tried to do something with it. If you didn't set it to nil, the pointer, after it's been released, would just be pointing off into garbage memory in RAM. And anything could happen. Your application could crash or whatever. But if you've set it to nil and they try to access that property, nothing happens. So it's a good practice to do that. You know, in your dealloc methods, because you're you know, about to exit, the object's going to be deallocated anyway. It's not something that you're really probably going to run into very often. But if you just get in the habit of doing it, whenever you release something, always set it to nil afterwards, then that's a good best practice to have. So we've kind of gone a long way there. You know, that extra bit at the end there about nil, not so much related to memory management per se, but more just sort of a best practice.
Now, this raises a question that some might have. Okay, this is a property. Yeah, that property might get set 6, 7, 8, 9,000 times during the life of the object.
Yes.
And every time I pass it a new string, in this case, into the property, it's going to retain it.
Yes.
But I thought, you know, it's very well that we then release it when we get rid of our object. But what happens to all the other ones?
All the other ones?
Other ones that we've been throwing in there, because we've just broken the rules, haven't we?
Well, not exactly, because the way that the accessors are actually written, when you, like for example, when you have a setter for one of these guys, when you've got, let's say we have a retain here, then the way that the accessor actually works.
Okay, so we're now going to simulate the code that the compiler is going to generate for us.
Right. I'm gonna sort of I'm gonna show what the compiler is actually going to generate for us. So we wind up with
which is good, because sometimes you want to write your own setter, so we're going to be learning how to do it properly. Yeah.
Absolutely. So ultimately, what actually happens here is you say it's actually going to, well, technically, here's what it's actually going to do. It's going to originally, ns string, it's going to grab the original value, so it's going to take the original value and it's going to store it off in another temporary variable. Then it's going to set the original value. Actually, it's just going to do. Then it's going to say prop equals in prop retain. So it's retaining that. It's retaining the new value that's coming in, and then it's going to say orig value release. So what it does then is it takes the original value, just sets it aside for a second. Then it takes the value that's coming in, and it retains that value, and then it releases the original value. So it's taking care of releasing the original value that was there for you, just as part of that setter.
Now, why does it put the original value aside and then release it afterwards rather than just releasing it?
Because it's possible that the value that you are passing in is actually the original value. And if it just released it right away, then it could be deallocated as part of your setter. And then so essentially, if it didn't do that, then just by doing that, you could wind up having a crash.
Oh, I see. If I'm actually passing in the same string that's already in there,
right,
and the first thing I do is release it.
Exactly. If I release it instead,
its retain count might reach 0.
Yes.
And then actually calling retain on it,
drop release first,
becomes a crash.
Exactly. If and of course, I mean, you might say, well, what if I didn't release it initially? Well, I'm assigning the value, so if it's not that, then I could have a leak, and so basically that's the reason that it does those things.
Right. So this explains why sometimes in code, especially old code before properties, when people are writing their own setters and gethers, you're going to see that sort of thing, or you might also see that the first thing in the setter is an equality check. Yes. Is this string equal to the string that's being passed in?
Yes, exactly.
Only if it's not do you retain it. In other words, if it is the same one, you just don't do anything. You just ignore the whole thing.
Exactly.
Yeah, so if people see that, that's why.
Exactly.
Okay. So we've had a fairly long and extensive bash at memory management. I know that there's more to go. So what are we going to be looking at next? So,
when we started even this segment, we talked a little bit about this NS auto release pool. And this has to do with auto release. And so that's going to be what we're going to talk about next.
Okay, so you just want to go digest what you've heard here, because this stuff is really, really important.
Exactly.
We don't want to be getting this wrong. A lot of the stuff we've been doing so far is about syntax. If you get it wrong, the compiler is going to tell you you've got it wrong and you can fix it. You get this stuff wrong, you're just writing bad programs that may or may not run properly. So take your time, make sure you understand what's just gone on. If you don't, watch the segment again, or as many times as you need to. And when you're ready, come back and auto release pools.
Bye.